Now start, ma'am.
Okay. So, on the behalf of Engineering College Bikaner, I would like to welcome one and all present here in the 1 week orientation program of Artificial Intelligence and Machine Learning using Python. The multidisciplinary online faculty development program organized as an effort to inculcate faculty members, general public, and scientific institutions about AI and machine learning. Before we proceed, I would like to notify all the participants that in order to be eligible for the certificate of the event, all participants will have to meet two criteria. Number one, 80% of the attendance is mandatory for the entire event. Number two, there will be a questionnaire shared to everyone at the end of the day, which will consist of 5 questions. And on final day, it will have 50 questions. So the participants must score aggregate 60% in order to be eligible. So participants fulfilling the above criteria will be provided the certificate. Now, I would like to take the opportunity to introduce our key speaker of the event, Sujatha ma'am. So,
Yeah. Good
ma'am, I
morning.
welcome. Very good morning,
Yeah.
ma'am.
Good morning.
Yeah,
Good
so
morning to all.
before we proceed and hear Sujatha ma'am, I would like to enlighten you all about her rich curriculum vitae. Ma'am, Sujatha ma'am has received her BE degree in computer science from Madras University in the year 2001. She received her ME degree in computer science from Annamalai University in 2009
Sorry,
with the
Anna
ninth.
University.
Oh,
Sorry,
it's
Anna
Anna.
University.
Oh, I
Okay. Yeah.
apologize. It's Anna University.
University.
Yeah, and ma'am has attained ninth rank in the university. She completed her PhD degree at Vellore Institute of Technology in 2017 in the area of data mining. And ma'am has a rich 17 years teaching experience, and she has been serving as an associate professor in the School of Information Technology and Engineering in Vellore Institute of Technology, Vellore. She has organized and attended a number of workshops and faculty development programs. Currently, she is guiding doctoral students too. She gives technical talks in colleges for the symposium and various sessions. She acts as an advisory editorial member and technical committee member in conferences conducted in other education institutions and in-house too. And ma'am has been awarded as IGEN Women Achiever 2021 in Future Computing category. So very congratulations for that, ma'am.
Thank
And
you, ma'am. Thank you.
her areas of research interest include artificial intelligence, data mining, machine learning, software engineering, soft computing, big data, deep learning, and blockchain. So a lot to say. So without any delay, I would request ma'am, I would love to share screen with ma'am. So I would request ma'am to enrich us all with her golden words. So over to you, ma'am.
Yeah. Yeah. Thank you. Thank you for your brief intro, ma'am. Glad to meet all of you professors. I guess all are from the different engineering colleges around and across India, I guess. So today, I'm going to just give it's like a warm up session, entire ideas about the machine learning and what are, hope I am audible. Am I right, ma'am? Uh,
Yes,
uh,
ma'am, you're audible.
Batma madam,
Yes, ma'am,
is
you're
it fine?
audible.
Okay,
Yes,
fine.
ma'am.
Okay, okay. Thank you, ma'am. So we are going to give like an complete information about what is the machine learning concepts. I'm not going to touch about that like deep learning concept. I'm just constraining me with the machine learning concept and few open source data mining tools and what's data repositories from where we can retrieve the information. And towards the end, I plan to show you one of the Python implementation of the very basic data set, heart disease detection data set. Okay, this is going to be like an flow of the lecture for this 1.5 hour session. So I hope like definitely you can gather some idea. I'm pretty sure it's not like a basic concept, but definitely you can get some idea out of this. So to begin with, so machine learning, so it's like a buzzword in this information technology area. So machine learning basically in the very initial days we used to write the program based upon the problem. Okay, each and everything will be coding, and based on that, will be going on. But with this introduction of this machine learning concept, the system can learn and it can train on its own, and then it can make on with the further processing, like a model could be made. So based on that, they are trying to give the fair example. So it's an ability to improve one's behavior with an experience, and ML explores to learn or build the model for the data and used to predict the decision making or solving the task. So it's really a very interesting area. And Mitchell, in the other way, has mentioned, like you can see the keywords like it's learn from the experience C with respect to some class of a task T and the performance measures P. So if its performance on task in T as measured by the P improves with the expression in the E. So as it starts learning day by day, the machine will become like an highly intelligent in nature. So I'm trying to give like a comparison between the traditional program and the ML based solutions point of the view. So in the case of the traditional programming language, we used to give the data and we used to give the program, and computer will work on it, and finally it will be generating the output. But on the vice versa, in the case of the machine learning, we'll be giving the data and at the same time we'll be giving the output. So what will be the combination of the data and what's going to be like an output point of view, that, and the computer will work on it, and then the program will be generated. I mean, the model will be generated for based upon this data and the output in the case of the machine learning. So it's like it's from the pragmat it's completely different from the programmatic solution, and we provide the input and the output data to the computer and generate a program model from the computer point of the view. Okay, these are the various keywords that I mean, this slide and the forthcoming slides will give us an information about how this particular process of the model building will be happening over there. So the task is like what are the various tasks of prediction, classification, and how in which environment it is working over there, and experiences, what are the existing historical data related to that and how it's going to be applied over for that particular task, and then based upon that output will be making over like in performance measures, so how far the model has been built properly or not. So and that concept, we are having this various components like a problem or a task, and the learner will be there who will be learning, and again you'll be getting some idea from the background knowledge, and based on that the model will be built over, and the reasoner will get still more ideas from the experience or the data, and finally the performance or the performance measure is one like an accuracy, precision, recall. As we go on, we can get inside each and every term. So accuracy, precision, recall of the constructed model will be started, I mean will be known over. So we are having n number of algorithms based upon each and every task. So what is an intention of the task? Based upon that, we are having a number of algorithms in this particular area, and we can even optimize each and every algorithm based on the requirement. So basically, like we need to train the experience, and then we have to choose a particular target function, and then how to represent those target functions, and then what sort of learning algorithm are we going to use to infer what sort of a knowledge sort of a thing. So this is a basic idea behind like the machine learning perspective. Any learning algorithm, we can even tell it like a neural algorithm rather than the machine learning or the deep learning. So we can tell like it's are the basic steps that will be followed in the case of the learning algorithm environment. These are the various terminologies. As a researcher, we should be so we very well knew about this. So algorithm is like it's like a set of rules in the statistical techniques. So we very well knew that each and every department is interdependent in nature in the case of the computer science. So we largely rely on the mathematical people. Okay, to be till more precise in nature, mathematics and statistics point of the view. So what's the numerical value and how are we going to interpret the numerical value? So we completely rely on some other. It's like an multi-domain. It's not like we will be working on independent. It's obviously the multi-domain. So similar based on this criteria. So algorithm, it's like a set of rules and statistical techniques used to learn the patterns from the data and draw the significant information from it. So basically, in the case of the patent discovery, okay, that's normally we'll be putting in the terms of the DM data mining point of view. We're putting a term of the patent discovery. So how are we going to discover the patent from the huge data? Okay, so due to this big data, in this big data, not as due to this big data, in this big data era, like number of data like it's created is so hefty in nature. So based on that, we are supposed to handle the data also. So that's what like it's like rules and statistical techniques, and the model is like it's a main component of the machine learning, and it is trained by using ML algorithms, and it maps all the decisions that a model is supposed to take based on the given input in order to get the correct output. So then comes like an other tricky words like the predictor variable and the target variable. So it's like a dependent and the independent variables. So certain variables inputs will have an impact on the output point of the view. So that's going to be like a target variable. It's an output variable that needs to be predicted by using the predictor. So whatever the values of the predictor variable, so based on that, we'll be getting the target variable in the output. And the next one is going to be like a training data and the testing data. So based on the size of the data set, we'll be segregating like this set of data is going to be act as a training data, and this set of data is going to act as a testing data. So normally we'll be going on at a 70-30 training. We'll be giving to the model like 70% to the training, 70% of the data will be given as a, for the training purpose, and the 30% will be uh, given as a testing data point. These are the simple terminologies which as researcher we all knew, I guess. So I'm coming on with this. So why are we performing this ML learning or learning algorithm? What is the need for this? So as I said, that data is generated. It's like an evolving in a. It's like an exponential in nature. It's not growing like a linear. It's like an exponential in nature. So we are in a position to handle this data effectively. So that's going to be like a primary objective. And again, when the data is going to be huge, deriving the decision from that is not that easy task. Like manually we can't make any decisions. So only with the help of the system and the machine learning algorithms or the deep learning algorithms based on the size of the data, we can go on with that. We can derive some decision. Okay, this is the pattern that I can, this is the trend I can see in this particular data, so this is how I can act over. So that's helpful in making the decisions and uncover the patterns and the trends in the data. So it's, as I said, like, so based upon the variable name, I mean feature name, and what is the description of the feature, and what's going to be the value of the feature. So it could be either like a numerical value, or it could be like a text value, it could be like an image data set, so, and it could be like an audio data set. We are having n number of a data. We don't have any restriction on, okay, this is only the type of the data. We are having n number of a data types, different data types are there. How are we going to handle that data? So when it is going to become completely numerical in nature, it's going to be one way of handling those data. So it'll be checking, normally it'll be checking on the missing values. So how are you going to handle the data? But in precisely we can tell whatever may be the type of the data, we are going to find out some pattern or trend from the data, which will help us to give clever and informative decision point of the view, and helps to solve the complex problems. So complex, obviously the data is going to be so huge in nature, the problem is going to be complex in nature, and it increases the productivity. And ultimately the latest trending topic is automation. Okay, automation of everything and intelligent automation. This is a current hot topic in the case of 2021. So this check on how you can see, or like an intelligent automation. So to make over like an intelligent automation, so data derived from the various sources required to be accumulated needs to be pre-processed, and then we can derive the pattern, or we can derive the decision, or we can derive the information from that. So that's the intelligent automation, which is like a hot topic as of now in the research. And coming on with an applications, it's not like only these are the application, it's having the application in the all the domains, all the verticals point of this. So in the medicine field, so in the case of the medicine field, so they'll be storing the health records of the patients, and they will be helped to retrieve like so what is the problem. So now you can see this in the case of an who we are having the dashboard for this COVID point of the view, corona cases point. So what it is trying to show us, like which particular country is having the higher level of this. So based on that, they can put this travel restrictions. So all those are like derived from the existing data set. So similarly, it's we can find it in all the areas like the financial domains, business intelligence, fraud detection, natural language processing area, robot control, and the vision. So as we go on, we can see few case studies pertaining with these applications in our presentation. So these are like an objective, and what are the various application of the ML. It's pretty clear, like application of the ML is like very vast, and we can tell like without that particular ML or a DL, none of the area is prevailing right now. Okay, so let's keep high on this machine learning process. So define the objective of the problem statement. So what for this analysis. So we are going to define that very clearly. And based on, it's like in general, like if you're going to take any software in any real time world, I mean real world problem. So what will become, we'll be getting our ideas, we'll be getting that what is the requirement for you people, and then we'll be trying to figure out like what are the required data to be accumulated for that. After that, we'll be start our working over there in the case of a software development. Similarly, in the case of the machine learning point of the view, machine learning process point of the view, we'll be finding what is an objective, what is the need for this particular work as of now, and then let's start gathering the data. So all would have heard a word called as a data warehouse, so where like it's going to be like a good own sort of repository or a good own sort of a thing where data will be accumulated. Okay, and based on the requirement, we'll be segregating the data from those, or we'll be making some normalizations or a min-max normalization standard scalar. So all those things could be done, and finally the data set will be ready for us to process on it, for us to apply the algorithm on it. So that's what the took us a data gathering. And then the other important thing which required to be considered over is like missing values and the duplicate values. So this missing values, how are you going to handle the missing values? So based upon the type of the data, we will be working on with this pre-processing steps. So when it's going to be like in complete numerical data, we'll be checking where the question mark is. Question mark indicates like the values are not available there, so missing values are there. So how are you going to handle that? So are we going to put the mean value for that? Are we going to put the mode value for that? Are we going to remove that particular record completely? Because we have to ensure like the lossless transaction is happening over there. So if something important is lost over, then it will create like an like not a reliable decision could be retrieved over. So we have to check out with all these possibilities, and based on the data set we can. And again, when the a number of data is so less in the case of the image processing, we will be going on with an augmentation where we'll be duplicating. I mean, we'll be trying to duplicate the similar images using the augmentation process. So based on the type of the data, the preparation or the pre-processing will be changed over. And the next step is going to be like a data analysis, so where we'll be understanding the patterns and the trends. It's like a visualization, we can tell. So for all sort of a data, we are first supposed to make the visualization. So another important other interesting research topic in this going to be checking over like a number of records fall in each and every category or a class or a target a label point of the view. So when it is going to be like a varied in nature, we'll be getting an imbalanced data set. So how are you going to handle that imbalance? Am I going to increase the number of records? So all those are like an interesting area where this could be done with the help of this exploratory data analysis, where we'll be visualizing the pattern of a data. So how many data are there, how many columns are there, what is the nature of the values of the attributes involved over there, so how many features are really having the impact. So you'd have heard a word called correlation. So we'll be finding what which particular attribute is having the higher correlation towards the target point of the view. So all those will be done with the help of the exploratory data analysis. And as usual, like Python helps us a lot in doing all these things. And we can work the Python in the Anaconda or the Google Colab or the Kaggle. And we are having so many open source tools also, which we can see towards the end of this particular PPT point of view. So like an open source tools, which makes the job of making the exploratory data analysis pretty easy for us. Okay, and similarly building a machine learning model from that. And while after this building the machine learning model, we'll be discussing about like what sort of optimizations are we going to apply. So how many cross validations? So if it's going to be like an 100 records, I'm going to check on with a 10 record sort of a thing. And we are having so many parameter tunings based upon the algorithm which we are going to consider over there. And based on that, we'll be either going on with the prediction, regression, classification, or the clustering point of view. So these are like an and the other one is like an association. These are like a major things that could be done with the help of the machine learning algorithm. So this is like a complete preview about what exactly happens in the case of the machine learning. Okay, so to come on with like what are the types of a machine learning. So this is purely based upon like an structure of the data. So what structure of a data are we having? So based on that, we are classifying this machine learning into supervised learning or the unsupervised learning or the reinforcement learning. So from the word itself, it's very clear, like in the case of the supervised learning, we'll be having the inputs, and what's going to be the output for each and every input is clearly given. The information is clearly given in nature, the supervised in nature. And in the case of an unsupervised learning, the data will be there, but the exact target label will not be mentioned over there. That's going to be like an unsupervised learning. And in the case of the reinforcement learning, it's purely like agents will be there at the middle who helps us to make the decisions point of the view. particular, that's mostly used over in the playing game sort of a thing. Okay, so coming on with the supervised learning, as I said in the very initial, so it's going to be like, and every data instance we have the input and X and then output Y. So number of inputs may be N number also, and the output is going to be one. And sometimes we'll be having the multiple outputs for each and every requirement. We can map the different output point of view. So it's going to be like a labeled data set and then supervised learning algorithm. So we are going to make all like a new observations model, and we'll be having the prediction or the classification. Okay, coming on with this word prediction or the classification. So the classification, in the case of the classification, all the values will be there, but finally the target variable will be categorical in nature. Okay, it's going to be like a category sort of a thing, or a discrete values will be there, predefined, I mean defined values will be there. That's a difference between the classification and the regression. So in the case of the regression, output will be continuous values. Okay, it will be having the continuous values, but in the case of the classification perspective, the output will be either like in categorical or discrete values will be the set of values will be there. So from that we can make or like a decision. So 0 stands for this, 1 stands for this. We'll be seeing what are the various data types too. So what is 0, what is the 1 stands for. So all those things we can make. So that's the difference between the regression and the classification, the difference between the regression and the classification. So using this regression and the classification, will be training the model, and for the prediction point of the view, we can give some records as an input, and we can find what is going to be the output for that. So that will be happening in the prediction point of view. That's what in the case of the supervised learning will be going on with the classification in the case of the categorical or the discrete values as an output, and in the case of a regression it will be having the continuous values. And finally, based on this, we'll be constructing the model, and from the constructed model we can make all the predictions by giving like a test data. So in the case of a test data, the final target variable will be question mark, or like it will be missing in nature, that needs to be received via the model point of view. That's what like about the supervised learning. And coming on to the unsupervised learning, in the case of the unsupervised learning, we'll be having the data instances, and we don't have like an output point of the view. So based on that values, we'll be grouping them together in the case of the unsupervised learning. So grouping like an similar characters together, and the way in which are we going to occur that's going to be discussed in the case of an unsupervised learning. And when some new instance is going to enter, so based on its values, we'll be checking with those three stuffs, and we'll be finding, okay, this particular instance can fall in this group. So we are not having the output, but we are trying to push that into that particular group point of view. So that's what it's in the case of the clustering. So this type of the problem involves assigning the input into two or more clusters based on feature similarity. So that's about the unsupervised learning. And coming on with the reinforcement learning, as I said earlier, it will be having the agent. Okay, agent will be there. So based upon like an action or a state point of the view, the agent will give the instruction what to do, how to do, or if it is going to be like not that good, what sort of penalties will be there. So all those will be given as an instructions in the case of a reinforcement learning. So these are the three broad categories in the case of the machine learning: supervised, unsupervised, and then the reinforcement learning. Okay, coming on with the framework. So already I have mentioned in the previous like what's going to be like a process happening over there. So we can see it visually in this illustration. So training data will be there, and this training data, it will be like flowing on the ML algorithm. So this is going to be like an ML model. So where input is given, so it will be working on an ML algorithm, and with this ML algorithm we can go on with the prediction, and similarly we can deploy the system based on the requirement point of view. Same thing, the whatever things which we have discussed, like pre-processing, all those things will be happening, but it's like a very very abstract sort of representation. Okay, so coming on with the other important keywords which as a researcher we should know is, so statistics. Any queries, ma'am? Professor Batna madam? Okay, so other keywords which we are supposed to know is like what is the meaning of a statistics, what's going to be data mining, and what is the machine learning, and what are the relationship between those stuffs. Okay, in the case of the statistics, it's a very evident, like it's going to be a greater part of the mathematical people. So we'll be collecting, analyzing, and studying the data and come up with the inferences and prediction about the future point of the view in the case of a statistics. And in the case of a data mining, the large data warehouse will be there, and with the help of this statistics machine learning database management technique, we'll be getting the interesting patterns. And the ML is an algorithm can learn from the data without relying on the rules based programming over. So this is going to be like give us a preview about like what exactly is different between the data mining. And you may ask like both are working with the data, but there are like important key things which we are supposed to consider over there. So in the case of the data mining, it's explorative in nature, and it's going to dig out and take like what's going to be. In the case of the confirmate, in the case of a status, it's confirmative in nature. So everything is theoretically present, and we are going to test it using the statistical tools. And in the data mining, it involves a data cleaning. But in the statistics, we are not having any data cleaning. We'll be collecting the data, and we'll be ensuring like while collecting the data itself, we should not have some missing values. So that's going to be like a very important difference between like a data mining and the statistics. And other things is in the case of a data mining, we'll be having the large data sets, but in the case of a statistics, it's not that large because it's going to be we are not considering about like cleaning the data stuff. So very perfect and prudent data only will be considered in the case of a statistics. And making the generous use of the heuristic thing, here we are not thinking about the heuristic thinking, and inductive process and the deductive process. And other main important difference between the data mining and the statistics is in the data for data mining, we'll be considering both the numeric and the non-numeric data. So we know like semi-structured data, so many data type. I said in the very beginning, it's different types of data that could be handled with the ML or a DL. So in the data mining, numeric and the non-numeric data could be, but in the case of a statistics, only the numeric data is considered for the processing, and less concerned about the data concern and more concerned about the data collection, because we are not having any data cleaning stuff in the case of statistics. And what are the various data mining methods is like an estimation, classification, neural networks, clustering, association, the visualization. And in this case, it's inferential and the descriptive mean mode. All those things comes in the t-test, p-test, all those things comes in the case of the statistic. And anyway, while we are going to present something, we'll be ensuring like it's going to have all the information. In the data visualization, we'll be drawing the box plot. It's a part of a statistics. In the data visualization, we'll be drawing n number of plots. All those comes under the it's a module under the statistics point of the view. And coming on with this next important difference between the statistics and the machine learning algorithm. Okay, statistics and the machine learning algorithms. In the statistics, it's more concerned about the inference that can be drawn from the model, and this we are going to focus on optimizing the performance point of the view. So it involves forming a hypothesis before building a model, but in this like we'll be running the model directly, and based on the data we'll be getting the trying the data. And it is all about sample population and hypothesis. It's all about the prediction, supervised, unsupervised learning. It's entirely different. Hypothesis will be fixing the hypothesis. This is going to be there. Are we going to prove it, or are we going to disprove? That's a way of inference in the case of a statistics. And converting the data into the help understand the structure in the data, and then this will be using the machine simulates the human learning sort of thing. That's the difference between the statistics and the machine learning. So it's all like in a single way, like determining statistics, machine learning, deep learning. And obviously the machine learning and the deep learning both is going to be a part of an artificial intelligence. So artificial intelligence started with the machine learning, but due to the growth of the data and due to the evolving research, it then moved on with the deep learning perspective. Okay, so other thing is like now we are going to see what is the data. So we are telling about the data. It could be numerical data or a non-numerical data. So broadly, there are like various types of a data classification. So this is one that we will be seeing about like two different types. So one is like a data could be qualitative in nature or quantitative nature. So in the qualitative in the nature, it's obvious like it will be like text point of view, good, bad, vast, or some that will be coming under the categorical. And in the case of the numerical, we are categorizing into continuous. So in the case of a discrete, so all the records will be there. It will be having either like a 1 to 5 value, 1, 2, 3, 4, 5. All these 5 values will be there throughout the records. In the case of the continuous, it will be like even like a fraction will be there, decimal will be there. All those things will be there. We can't predict the any sort of inference from that. That is the reason we'll be using the regression in the case of the continuous point of view. So it's like gather the body of the facts and central thread of any activity, and it's broadly classified into the qualitative and the quantitative. This is the one way of representation of the data in a very generic manner. So other way of representation in the case of the data is going to be like a nominal, ordinal, interval, or a ratio. Okay, so these are like another way of the representation. So what sort of a data is going to be there? So based on that, and as we see, the other key factor in this case is like, so they ordered with this increasing factor. So accuracy will be increased from nominal to ratio. The accuracy will be increased over the powerfulness of the measure increased over, preciseness will be increased over, and it finds wide applications. As we go on, this NOIR will be having the different attitude. Okay. And coming on with this nominal, so what do you mean by this nominal? So in the case of this nominal, we'll be going on with this name and the count. So for each and every value of an attribute, we will try to fix a code for that, or some standard code for that. So that's going to be like a nominal point of the view. So gender, it's going to be either the male or a female, so M or F, and it's going to be marital status, a married or single, or so married for M and single for A. So this is a way of representation in the case of a nominal. So our data will fall. Obviously, our data will fall either in the quality or the quantity. That's going to be one way of classification. The other way of this is like either whether it is going to be nominal or ordinal or interval based or the ratio based point of the view. So you may think like why I'm discussing. So all this are like a part of the exploratory data. Only when we knew and thoroughly about the data, we can work on with the further algorithm or any sort of a thing. Okay, so that's the reason I thought I can give you like an idea about this nominal or and coming on with an ordinal, it's like a rank sort of a thing. So it's like a place even in the order. So you can very well see like undergraduate is less than the graduate, graduate is less than the postgraduate, postgraduate is doctorate. So it may resemble to certain extent like a nominal, but we are having some relationship or a scaling between each and every value of an attribute point of the view. So ordinal means rank or order, and it plays events in the order point of the view, and they are ordered categories like a ranking or a scaling, and it allows for setting up the inequalities and nothing much. So that's what like they're trying to show in the case of an ordinal data. And coming on with the interval point of the view, so interval data in addition to ranking further allows for forming the differences. So that's going to be like the interval point. So temperature in the Fahrenheit or the standardized scores, all those comes in the case of the interval. And in the case of the ratio, we will try to mention like this is greater than that, that is greater than. So that sort of things will be in the case of the ratio data. Allows for forming the questions in the adding to setting up the inequalities and forming the differences. Okay, so as I said in the start of this data type, so as it increases over, it increases the level of information or a statistical manipulation, and that is a way of inference in the case of a NOIR, nominal, ordinal, interval, and then ratio types, ratio data types. Okay, and coming on with discrete and continuous, as I said in the categorical stuff, so numerical data could be either discrete or a continuous, and it takes any numerical values, and it can be infinite number of passable values in the case of a continuous data. But in the case of a discrete, we'll be having like a limited number of values over there to make or like a mapping with the other target labels. Okay, so comparison of the discrete and continuous is more precise than the discrete, obviously, and more informative than the discrete, but it's tough to handle. Continuous data can remove the estimation and rounding of the values, and it's often more time consuming to obtain. And discrete should also be converted to the continuous data when possible as to obtain a higher level of information. Okay, and they're trying to give this comparison like in the case of the attribute of the discrete, how we'll be mentioning that. In the case of a continuous, how are you mentioning earlier? So now if you're mentioning like a gas tank, either it's going to be empty or full, is going to be discrete. But if you're going to ask for the volume, it's going to be continuous value. So we maybe have some threshold value. If it's going to be like an 20%, then we'll be putting like it is like an empty in nature, but we'll be putting here 20%. So it comes under the continuous. So similarly, tree heights, tall, medium, short, we'll be putting like short is like within like 5 meters. If it's going to be 5 to 20 meters, or the 20 to 40 meters. So we'll be making the, so that will be the way of inferences in the case of the discrete and continuous. Similarly, in the case of a performance, poor, average, and good are like actually in the company, they're trying to find the performance pieces per hour. So within per hour, like how many pen or pencils or rubber they are producing over there, and they'll be trying to map the discrete point of view. These are the just an example how the conversion between the discrete to continuous or the continuous to the discrete could be done over. And it is very pretty sure like continuous will be having the higher level of information. The discrete is going to be like an abstract way of representation of the continuous values of the attribute point of view. So this is like what are the various data types and how are you going to work on it. So next we are going to enter inside the data mining techniques. So all this classification, association, prediction, clustering, sequential patterns, decision tree, all those are like a part of a DM technique. Okay, so coming on with, before entering inside in a case study, I just want to show you like a glance what are the variables machine learning algorithms existing in the supervised or unsupervised point of view. So in the case of a supervised machine learning, so we very well knew like we'll be pretty sure about the class label. That's what like I'm telling from the very beginning. So based on that perspective, we'll be having like on the case of a discrete point of the view, we'll be having the two types. One is going to be like a two class and other one is going to be like a multi-class classification. So these are the various algorithms: logistic regression, decision tree, decision jungle, support vector machine, SVM, boosted decision tree, bias point machine. So all this could be like for the two class classification point of the view. In the case of the multi-class classification, we'll be using this decision tree, logistic regression, random forest, and then the gradient boosting tree, naive Bayesian decision jungle. All this will be used in the case of the multi-class classification. And coming on with the regression, as I said, it's going to be applied in the case of the continuous value of the target label. So they will be having this so many regression and anomaly detection to ensure like an outlier handling over there will be going on. We are having so many algorithms. And similarly, coming on with the unsupervised machine learning algorithm. So normally we'll be having the more attention towards the clustering and association. And dimension reduction is when the number of records, when the number of attributes are more, how we are going to retrieve the knowledge in a very easier manner. So there will be having the dimension detection stuff, and then recommendation system, and then the computer vision and the text analytics. So all those comes under the unsupervised machine learning. So where the target label is not given over there, like output is not mentioned over there, based on the values of the input of the various attributes will be mapping on with that particular group or a cluster point of view. Okay, and coming on with the real-time example for each and every, we will see about the classification, and we can see about the clustering example, and we can see about the association. So these three steps we can see with the various examples. So in the case of the classification, so it's like given a collection of records that's going to be a training set, and each record contains a set of attributes. One of the attribute is a class, that's going to be like a target point of the view, and we are going to find a model for the class attribute as function of the value of the other attributes. And its previous is or unseen record should be assigned a class as accurate as possible. So training and the testing set. So testing set should be assigned a label. So that's going to be like an ultimate goal in the case of the classification. So while we are seeing it, it's like okay, easy sort of thing. But while we really work on the real-time project, we can come across like an n number of problems. It's not that easy, like you'll be telling okay, it will be running it, but it's not. So really when we start working, we'll be facing some real-time challenges. We may thought like this is fine, that, but we need to fine-tune each and every stage. Okay, now this be an example for the direct marketing. So the goal of this is reduce the cost of mailing by targeting a set of customers likely to buy a new cell phone product. So you would have seen like number of surveys will be conducted. Even we used to get like in surveys either in the mobile or in the from some of the websites you'll be getting this what to say, a survey about the product. So ultimate aim is they'll be trying to figure out like are they interested to buy the product or not, so at which time they may be buying the product. So during that, like how are we find them. So all this comes in the case of the direct marketing. So reduce the cost of mailing by targeting a set of consumers. Instead of dropping to all the people, they'll be saying, okay, this set of a so now, for example, when you are going to start some shopping also, you'll be thinking like which particular group we can focus on based upon the product point of view. So that's one of the thing in the case of the classic use case of this classification. So use the data for a similar product introduced before, and we know which customers decide to buy and which decided otherwise, and this buy don't buy decision, all those things, it's just one of the case study of the classification. And similarly other thing is going to be a fraud detection. So normally we'll be seeing like credit card transaction when you're going to transact like a very higher level of amount, like 50,000 or 60,000. So immediately we'll be getting a call from other side, like are we using that or not. And other thing is like how are you going to find like a loyal customer for providing the cards also. It's not like all are like going to pay the amount properly. So how are we going to, so all this be done with the help of the accumulated data. Okay, it's not like immediately we can do. With accumulated data in transactions we can drive so many informations. And similarly the customer attrition or return. So this particularly used in the telecom industry. So the telecom industry is the one which is seeing like a lot of attrition. So we'll be today in the Jio, and tomorrow we'll be going to the Airtel, and the next day we'll be going to the BSNL. So it's like a human attitude to ensure like we are not going to pay more for the thing which we are getting. I mean, which we are getting. So how are you going to ensure that? Again, if you are going to give for some disconnection for some of the network, immediately they'll be calling what is the reason for this. So then you'll be telling tariff may be high. They'll be telling okay, I will waive some tariff, so some sort of thing. So how are we going to figure out this? That's a process of this customer attrition or churn. Obviously, it's going to be based upon the data sets which is with them from the particular customer point of view. Okay, so here we will detailed example of classification example. So in the case of this was like an work carried out by this Duda and Art. It's in the 2001. It's a pretty old work. So their thing is like they're trying to automate the fishing industry, that fish getting industry. So they are getting they're catching the fishes daily, and they want to segregate that into the sea bass or a salmon. Okay, these are the two type of the fishes. They can see that, but they're not able to immediately visualize which is a sea bass or a salmon point of the view. So using the optical sensing, they are trying to figure out this. So based on this, they are listing like these are the features that is going to be considered to classify the fish either into the sea bass or a salmon. So it's based upon the features like length, lightness, width, and the position of the mouth. So based on this criteria, they are making. Okay, so based on that criteria, we are mentioning like pre-process. Going to classify. So to have basic domain knowledge, whether the fish is a sea bass or a salmon, it's purely depend upon the value of the length. Value of the length. So common thing they have mentioned is sea bass is longer than the salmon. Now they are going to try to keep one threshold value for this. So what's going to be the threshold? Where how are they going to? So see, like now they're going to make the training classifier. So fish length and the fish name, and then they're going to make like a training examples, and based on that they are going to make the classification. Okay, and once we get a model out of the classifier, we use the classifier to test further examples. Okay, so now you can see here, it's length is given and the fish name is given. Okay, so 12 and it is salmon, and then 15 and then the sea bass, and then 8 it's going to be salmon, and then 5 it's going to be sea bass. So now they are trying to construct the model, and it's not sure, like always, like when I try to construct, it will be getting the model, but it's not like in 100% accurate in nature. Certain discrepancies will be there. So now as per our understanding, they're trying to make over that if the length is greater than 12, then it is going to make like in sea bass, else it's going to be salmon. So now the model is constructed. So once the model is constructed, then we are going to give the test data. So where it's going to be like in question mark, which indicates like value is missing particular for the particular attribute or the particular record point of view. So now it's going to be, so we have mentioned very clearly length is greater than, so we have fixed this threshold value, length should be greater than 12. In this condition, we are just checking on with only one stuff, length point of the view. It's not so. Based upon the domain knowledge and understanding, we can even club up with still more attributes also to make the model still more accurate in nature. So now like in 18, so 18 obviously it will be falling on the sea bass, and when it's going to be that, it's greater than 12 obviously, so it's 8 means it's going to give that as a salmon. So this is going to be like an evaluation or the prediction point of view. I'm going to train with the various data which I'm going to receive, and based on that I'm going to construct the model on the condition point of view. So that's like an example based upon the fish point of view. And as I said earlier, decision tree is another one way of making or like a classification on the prediction point of view. So here you can see like a number of attributes they are considering. The first criteria is like in salary, and then they are thinking about like how much am I going to commute, so how far it is my company is going to be, and they're going to offer the coffee over there. So these are the three attributes. Based on these three attributes, I'm going to decide whether to accept the offer or decline the offer. So now very well we can understand like the salary is going to be like a numerical value, and the commute is again going to be the numerical value indicating like a number of hours or a minutes. And again the offer of the free coffee, it's going to be either 0 or 1, I mean yes or a no point of the view. So when a person is, this particular person is trying to check on with some other new job, but he's having like an salary should be greater than $50,000, then only he can take up the new offer. And at the same time, the commute more than 1 hour, if it's going to be there, whether is he going to accept or not. And again, he's going to check like whether free coffee is offered or not, then only he's going to. So when you can see like when this condition, so a salary is going to be 10,000, so obviously it will be declined in this particular stage itself. So now the salary is going to be 60,000 and the commute is going to be 2 hours. Again, it is going to be declined in nature. So now the salary is going to be greater than 60,000 and commute is 30 minutes and the coffee offering is no, then it is going to be decline the offer. And otherwise 60,000 and in 30 minutes, yes, then only it's going to be accepted over. So this is a way of representation of how are we going to take the decision. So decision tree, how the decision tree works internally. So now they're trying to find one example, like whether a person is like a loyal customer or not, where you can just transfer, so it's refund, and then marital status, taxable income. So these are like in training data. So using this training data, they are constructing the classifier, and in turn like a model will be constructed over there. So to figure out like whether you will be cheating or not, they are trying to give the cheat. So this based on the decision tree action, they can make the chart sort of a thing, and they can find some value. So now see like a taxable income. So in the case of a taxable income is going to be like an 95,000. Okay, taxable income is 95,000 and 85,000 and a 90,000. Is a cheater. Okay, he's a cheater. So I can make the inference like if it's going to be greater than 96,000, greater than 96,000, he is not a cheater. Is not a cheater. So this is a way to make the inferences. So this could be done when we are applying the machine learning algorithms. Here I'm just saying the inferences. So how many are S there? So they're having the S in the three places. Okay, so based on this criteria, one inference I can give is taxable income is greater than 96k is not a cheater point of view. So this is a way of inference. And similarly, based on all of this idea, we'll be getting the confusion matrix. Okay, in the machine learning, we'll be getting the confusion matrix. So on this, it's going to be like in prediction and actual and the predicted value point of the view. The terminology is a positive means the observation is positive. Negative, it's observation. It's not a positive point of view. So in the case of the true positive, so both the predicted and the actual is going to be true. Okay, it's a positive in nature. It's going to be like a true positive. And then in case of the false negative, I predicted is correct, but actually it's not so. The other, it's not at all possible. It comes under this type 1 error or like an sort of a thing. Okay, so you can just, I guess, a confusion matrix you all knew about. So true positive, and then the false positive, and then the false negative, and then the true negative. So based on this criteria, we'll be getting the other performance measures like accuracy, recall, precision, and F measure. So for any sort of the machine learning algorithms or the learning algorithms that you are going to apply in the case of the classification, okay, in the case of the classification, we'll be working on with this metric. So accuracy. So obviously all this value should be higher in nature. So normally it will be between 0 to 1, or we can call them like a 0 to 100% sort of a thing. So based on the values of this true positive, true negative, we'll be arriving at this classification metrics. And coming on with the other thing is like ROC. So again, the ROC will be like near like an 0.9, nearing like a 0.9 to the 1. So which indicates it's actually the graph between the false positive and the true positive rate. So ROC should be normally between 0 to 1, like closer to 1 or a 0.9 is a good model. Okay, the model which we have constructed is good in nature. Okay, and then coming on with the clustering. So in the case of the, so we have seen about the classification. So we have seen in the case of the values point of view. Similarly, in the case of the what to say that continuous values will be having the linear regression. So regressions will be there. So where we'll be getting like in y is equal to ax plus b. So a and b are like a continuous value. X is going to be like a constant, or like either way. Like, so how are we going to work on it? That will be in the case of linear regression. And coming on to the clustering. So clustering falls under the unsupervised learning, and it's similar to one another with the same clusters, dissimilar to the objects in the other clusters. And ultimate aim of the clustering is group the similar things together, or similar points of view. So data points in one cluster are more similar to one another, and data points in separate clusters are less similar to the one another. So when we are trying to make on with the training, we'll be making the training using the n number of algorithms, and then we'll be mapping using the testing phases. So the clustering applications, like similarly it will be used in the marketing or the land usage point of view, or the insurance point of view, or the city planning, or the earthquake study. So these are the various applications, and certain applications will be like a meet in middle between the classification or the clustering. So it's, as a researcher, we should be in a way to find out like, so what sort of algorithm could be used, what sort of task could be performed with a particular data set. Okay, and coming on with the clustering point of view, so it's, as I said, it's high intra-cluster similarity and the low inter-cluster similarity point of view. And the quality of the clustering method is also measured by its ability to discover some or all of the hidden patterns. Okay, again, now we are trying to figure out like when we'll be using the classification, when we'll be using the clustering, and when we'll be using the regression. data correlated or redundant, if it's going to be correlated or redundant, then we'll be applying the dimensionality reduction to reduce the attributes or reduce the to the required number of attributes point of view. Otherwise, we are going to go on with is producing a category. If it's going to be categorical in nature, we are going to the label will be there obviously. So based on the labeling, S, it's going to be going to the classification task. If it's not having the labeling, it will be going on with the clustering task and coming on in the other way. So it's like qualitative and quantitative, so numerical in nature. So S, so it's going to be it's data producing a quantity. S, regression, and if not, it's going to be like, okay, we have to check on with the values of the attributes that was given in the data set point of the view. Okay, and coming on with the this again comes under the unsupervised learning, association rule mining. So from the word association, we can very well infer that what influences the other. So how much impact one has with the other. So that based on that, we'll be having this association rule mining. So antecedent. So if what is going to be the rule and then what is going to be the consequence for that. So based on that, we'll be having this association rule mining. And similarly, in the case of an association rule mining, the performance measures. So in the case of the classification, we have seen like an accuracy, precision, recall, all those things. And the case of a regression, we'll be having like an error values, RMSE values, MSE values for the performance measures. And in the case of the performance, in the case of the association rule mining point of view, we'll be having this support, confidence, lift, benchmark, confidence, and then lift value. So obviously all the values should be like higher, I mean, nearing to 1, which indicates like perfect association rule appeared and perfect matching is secured over sort of a thing. So that's all about the association. Okay, just relax for a few minutes. Okay, so just we'll enter inside like what are the various open source and the free source tools available over there. So you can see in this like one picture like data never sleeps 9.0. So this is like organization called as in Domo. There'll be each and every year they'll be giving this stats about like how much internet is used and how much of data is generated in each and every social media or in precise like a network point of the view. So it's like in the due to this pandemic, the usage of the internet population is increased across the globe. And you can see here at the beneath, like in the 2021, it is like an 5.2, and in the contest of 2020, it was like 4.5, something like that. So it keeps on increasing over there. This is one makes the uh, big data analyst or a big data engineer or a big data scientist as a potential area of work or a potential area of research. You can very well see like in the case of the Facebook, it's like in 240,000 photos or user shares happens for each and every minute. And similarly in the case of the YouTube, like 694,000 hours of like an user steams it for each and every minute point of view. It's really like will give you like a taste of like how the data is evolved or multiplied in a enormous manner. Okay, so to get inside this, I first I'll be giving like what are the various. You can just note this data mining tools, and you can definitely work in your use it in your research work. Okay, the first tool which I try to give you preview is like an orange tool. Okay, this orange tool, it's all like a drag and drop. You're not required to do the coding. It's all like a drag and drop, and where we can do like an excellent EDA, exploratory data analysis, excellent visualization could be done with this. And again, we are having n number of the machine learning algorithms that could be applied over the data set which we are going to take over, like, and widgets are there for each and everything. Widgets are there, so we can use the text mining also. We can do the image processing also. We can do the genomic sort of research work also. So we are having n number of time series analysis could also be done. All sort of things could be done with the help of this orange data mining tools. I use this particular tool very often, and the results from this I used in my research work also, and published that paper in a nice journal too. Okay, and then other one is the Veka tool. It's also similar to the orange. It's going to be like in free software, where we can even fine tune based upon the requirement. And here also we can handle the, I mean, in the both the orange and the Veka, we can in the case of an orange, we are having like a nice methodology to handle the missing data too. So that in the case of the Veka also, it will be having like a provision to work on with the imbalanced data set. But in the case of the Veka, normally it will be working on with the numerical values, it means CSV file sort of things only, or the ARFF, I mean attribute relation file format that is used in the case of the Veka. So in this, we are not in a position to use the various data types, but in the case of the orange, we can use with the n number of data types. And this Veka is developed by the University of Waikato in New Zealand, and it's works based on the Java programming language. And the KNAM, it's again another one open source software where we'll be having like an you can use one of the various machine learning algorithms could be utilized over there. And the rapid miner, so I guess like so many may be using this rapid miner also. So it's like an integrated environment dedicated to the machine learning and the text mining. So the way in which I am showing is like based on the user interface point of view. The orange is going to be so easy to use, drag and drop. The Veka is also so easy to use. As we go on, like the user interface will quite different, or like a certain code should be written sort of a thing. Rapid miner, and other one is going to be like an Apache Mahat. It's going to be like a project developed by the Apache Foundation, and in this it's written in the Java and include the Java libraries. And algorithm of Mahat have implemented a level above the Hadoop also. It's also that map reducing templates, all those will be there in the Apache Mahat. And in the case of data melt, it's again one of the open source and computation and the visualization environment. It will be running on the Java virtual machine sort of a thing. And other one is in Metabase, so it works based upon the SQL point of the view. Beautiful graphs and the charts we can get by using this Metabase. And other one is an OpenRefine, and this OpenRefine also, the speciality of the OpenRefine is it's available in multiple languages, multilingual in nature, this particular tool. And it is very meant for like an pre-processing sort of a thing. How are you going to do the pre-processing? This is particularly meant for the pre-processing, and this very user friendly in nature. And other one is Talent. It's customers connect anywhere at any speed, and from ground to cloud and batch streaming sort of a thing. It's again a part of a data mine. Okay, so all these are like an very handy open source too. If I ask me, I'll be telling like you can use on with an orange, Veka, and then the OpenRefine. So all these are very user friendly in nature. Other requires some effort. It's not like it's not tough, but it requires some input sort of a thing. Okay, and then I want to show you some information related with what are the various repositories where we can get the data also. So Kaggle, so hope many will be using the Kaggle data set. So the main advantage and the disadvantage of the Kaggle is, if you are like an fresher sort of a thing, you can just work on with the Kaggle in the notebooks. Okay, in the notebooks which we are shown, you can just start working on the notebooks. But the thing is like certain journals are not accepting it as a benchmark data set, because anyone can upload the data and anyone can make sort of analysis. So certain journals are not accepting the Kaggle data set as a benchmark data set. And other one is going to be like an UCI. So I have shown that Veka tool, no? So this is the relationship between this Veka. I mean, both are like an brother sister sort of thing. So there we are having n number of a data set, and it is like a benchmark data set. If you are going to write a paper with the getting from this UCI, definitely it's accepted over there. And then this is like an India statistical data sets, like Indian Kenoma. It's keep on growing. Okay, just I've taken this bit old, but it's keep on growing sort of a thing. Another interesting thing is in keel. Okay, in the case of the keel, even we can make or like certain working also. So knowledge extraction based on evolutionary learning, and it is going to be like again open source Java software too that can be used for a large number of different knowledge data discovery tasks. So you can even see this very interesting. The skill is going to be very interesting in nature. Apart from this, I want you to just take the note of it. So Google data search, but as of now, from last 2 days, Google data search is down. Okay, it's not working. So this the passkey point of this Google data search is it will be searching from all the repositories, and it is giving the information instead of checking each and every repository individually. Using the Google data search, we can get the information about that particular. If you enter the keyword, it will be showing like, and again obviously all the filters are there, but as of now, for the past Friday, I'm just seeing the Google data set search is not working. And then other one is like in zenoda.org, that's going to be like a nice data set. And similarly DeepMind, it's about like good amount of data sets, and the research papers are available in this DeepMind. And similarly data.world, and then the data.538.com, it's again gives some data along with the articles point of the view. And data.worldbank.org, so if someone is working on the financial perspective, they can rely on this data.worldbank.org. But I have given the data sets, but few data sets are available free of a cost. Few data sets are we need to pay for that, and the few data sets author is going to provide based on the request also. That also happens, and obviously as a researcher we are going to give them the acknowledgement. And the other one is like a data.gov, so it's like an US government data. And then msropendata.com, it's like a Microsoft's data point of the view. And similarly registry.opendata.aws, it comes under the Amazon web services related data set. And in the case of a GitHub, so again the GitHub and the Kaggle, so both have the problem of this benchmarking sort of a thing. But in the case of the GitHub also, as we very well know, we are having so many public data sets, and so much of coding also could be referred from the GitHub. And then the other one is like an YouTube sort of a thing. From the YouTube we can make some analysis sort of a thing. And then the Dataverse and Harvard, so the Dataverse and Harvard is really a very 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 good data repository, and it is completely free in nature. But we should have the patience, because data, it will be showing like a Dataverse, a data set and the files. So if we spend some time slowly, we can get nice data sets from this Harvard data set also. And apart from this earthdata.nasa.gov, so where we'll be getting the data related from the earth point of view. And if someone is working on the crime point of view, they can check on with this crime data. It's under the FBI. So even in our India also, we are like an NCRB, National Crime Record Bureau. And apart from this, another one which I missed is like an Mendy data set. So Mendy is also having like a nice data set. So it's just like an idea I've given, but it's not like only this. We are having n number of data repositories, but only time is like, and again, if you think about like a medical, if you're working in the medical field, we are having n number of medical field, like ultrasound, they'll be having data sets, and for the low resolution images, they'll be having set of data sets. So we are having plenty of data sets. And similarly, it is going to be like an cancer or a lung cancer. For each and every cancer, we are having separate. And other potential area of the work is video classification and audio classifications also. Okay, and this is another one interesting site which will be giving us an update of each and everything very frequently. KD Nugget, so it's giving about like top stories and what is the field right now, where are we right now, and what could be the next move of the IT point of view. So all this will be received via this KD Nuggets. We are having n number of things, but I feel like for the past few years I am watching all this stuff which is like good in nature, and they are maintaining the quality point of view. Okay, as I said, we will just see one example for the in the Python, in the Kaggle. I use in the Kaggle, and I used to work in the Google Colab. So we are having like an 14 attributes, this heart disease data set. So what is this 14 attributes? So age. So age is going to be continuous. So obviously it's going to be continuous in nature. And then a sex, it's going to be either the male or a female. So it's going to be like in categorical in nature. And then the chest pain. So based upon the value, either it may be falling in this typical angina or atypical angina, or non-anginal pain or asymptotic. So based on the type of the pain, they are going to categorize into any one of the steps. And then resting blood pressure, what's going to be the blood pressure, and what's going to be like in cholesterol serum, I mean cholesterol level, and what's going to be like in fasting blood blood sugar level of a patient, and what's going to be like an electrocardiographic result. So whether it is a normal or having the it's all like medical terms. STT wave abnormalities are showing the probable or definite left ventricular hypertrophy bias. So then in that, and the minimum heart rate achieved, and what's going to be like an exercise induced angina. What's going to be the value sort of a thing. So one or a is a zero or two. And similarly, old peak ST depression induced by the exercise relative to the rest sort of a thing. And the slope value, so based on the turn sloping, flat or a down sloping, and the number of major vessels colored by the fluoroscopy. So fluoroscopy. So it's like based upon the some biomarker sort of a thing, and then tal normal or a fixed effect or reversible, and finally it's going to find whether the patient is having the heart disease or not. Okay, this is just a very common and a simple example which we are going to check over, and these are my recent publications. So in the case of this deep learning versus machine learning in the plant leaf disease, you can check that I have used the orange for the complete working, if I remember correctly. And in the case of this Bayesian regulation, I use completely the MATLAB for the entire working. And in the case of this machine learning way to classify the autism spectrum disorder, partly I use the orange only, I guess. And in the last two papers, I use the Python, I mean Google Colab or the Kaggle for the next two papers. Okay, so it's not so like this open source tool is not good or something. You have to think, or like how are we going to use our. Okay, so that's it. So I want to show you the uh, hope the Kaggle thing is visualized, right? Yes.
Yes, we can visualize.
Yeah, are you interested to work parallelly with me or which way? Hello. uh, are you people going to start working in the Kaggle parallelly, or which way do you want? Someone can reply, I guess. Hello.
Um, Hello, participants.
Yeah. Uh,
Hello,
can you?
participant. Are you agree to the parallel work with ma'am? No, ma'am. I think no one is interested for
Yeah,
that.
yeah. Monica has given a concern. Like, so can you just open? It will be easy for you to go through. Also, just I'm just checking. Okay, till this time I given the theoretical part. I want you to people to work also. So you can just download the UCR. You can just open the UCR. No, no, sorry. Okay. I want to attach the file. Actually, I'm trying to attach the file. Uh, okay. Someone can tell where is like in attaching the file options there. Yeah. Hello. Someone can help me to attach the file. Hello.
You want to
Uh,
attach the file into Google Messages itself?
yeah. I need to. I try to attach the
No, no,
file
no.
here.
I think that facility at this point of time, I don't
It's
think it is
not there in
there.
the Teams. We have add
Mhm.
on WhatsApp. So
Okay,
hope
what you will do?
you are
What
having
you
WhatsApp group with Professor Vishal. Am I right?
uh,
Yes, Professor Vishal, are you having the WhatsApp group for this
yes,
set of
Yeah.
people? Yeah, I
Yes.
will send it to the Professor Vishal and they will send it immediately to you.
exactly,
Okay?
exactly. You can send to the
Can you
Vishal
make me
sir.
a favor? Yeah,
Yeah. Okay. Okay, ma'am.
yeah,
You can share to Vishal sir. He will send it.
yeah, I am sharing.
Okay.
हाँ सर। हाँ सर, बताएं। सर वो की नहीं हुई, वही कर रहा हूँ सर, लेकिन वो इनके मैम कुछ बता रही है ना, वो कि मैं भेज रही हूँ तो उसको फ्लोट करना है। हाँ हाँ, अभी एक सेकंड। हाँ, कर दीजिए सर, आप कर दीजिए।
Yeah, I sent. Professor Vishal, I have sent. Hope it reached you. Professor?
Hello, ma'am. Yes. Have you sent it?
Yeah,
To,
yeah, I have sent to Professor Vishal.
sure. We'll float on the group. No, no issues. No issues.
Yeah.
Yes
We'll,
मैम, आई
So we
फ्लोट इन द ग्रुप में।
yeah. So I want you people to take that. Attendance link came fine. So because it's going to be time consuming. So actually, hope all would have received the CSV file. Yes.
you were saying
Yeah.
something, ma'am?
All would have received the link. I mean CSV file, I guess, from Professor Vishal.
CSV. All the files are CSV files. Is it?
No, this data file, hard.csv, comma separated value format to
Yeah.
start working in the Kaggle.
Okay. Okay.
Receive? All would have received, I guess.
Vishal sir will be looking at his mail ID and then he'll.
No, I've sent in the WhatsApp, no mail ID WhatsApp.
Okay. Okay. On WhatsApp. Okay. Fine. So he might be
No, I guess it is received. Got on WhatsApp. Yeah, thank you.
done.
Thank you, Professor. Okay, so
No sir, I have sent it to the group, sir. Please check sir, I have sent it to group.
Yeah, it is there.
yes.
There on the group.
Yeah.
No issues.
Yeah, okay. So now hope all can enter the Kaggle. All will be having the login in the Kaggle, if I am right. Yes. It's nothing like you can just enter and you can give your Gmail ID and enter inside the Kaggle platform. Or if you feel that way it's tough, you can just start going on with the Google Colab also. But any one platform, because all like we use the Python very frequently nowadays. Enter inside the Kaggle. So Kaggle will be like this. And I have logged in, so it's showing. So otherwise you are supposed to log in here. So have you logged in? Can we start the session?
Yes, ma'am, you can. Please go
Yeah.
ahead.
So once if you go over, like you'll be getting thing like this, and in this add data we can go and we can add our data. Okay, so we can add our data, required data inside this. So now hard disk is UCI, this is the folder. Inside the folder I am having this r.csv file which I have sent to you right now, and we can copy this by, if you're going to this extreme right, we have this copy file path option to copy it. So once if you open this in the Kaggle, you can see like notebook option will be there. Okay, you'll be having an option called as a notebook. If you just click on the notebook option, this particular window will be, this sort of window will be open. So once if you open this window, I'll just tell you like what are the other things needs to be checked over. So in the settings, you have the option for running in GPU or with the CPU also. So when the data set is, since it's like a small data set, we are not going to run in the GPU. So when your data set is quite hefty and it is going to be like an image sort of a thing, or an audio sort of a thing, or a video sort of a thing, then you can check on with this GPU stuff. And you very well knew like normally our old laptops are not having the GPU facility. So to overcome that, we can either use this Google Colab or a Kaggle, which provides a provision to work on in the GPU environment. It will be a bit slow, but it is manageable sort of a thing. So now it's simple data set, so I'm not going to go on with the GPU environment, I'm just going on with the CPU environment. So once if you start, you have anyone open this Kaggle environment? Jupyter notebook is also open. I am not denying, but in the case of a Jupyter, like still more processing required, or like and downloading or installing, all those things are there. But in the case of the Google Colab, since now we are like a researchers, we are not like a school, I mean college. If it's going to be like in college students, we explicitly tell that you have to go on with the Jupyter notebook, you have to work in the Anaconda platform, you have to install the Anaconda. Inside the Anaconda, we have all this orange we are having, and we are having the also many art studio, all those things are there. But now we are like on the research point of view, it's enough if you work on with the Kaggle or the Google Colab environment. It's not required to want with the each and every time with the Jupyter sort of a thing. Okay, so let's get inside the insights of this stuff. So import numpy as an NP. So it's meant for like an machine learning algorithm sort of a thing. And then import pandas as a PD. So where we'll be having a data processing start or exploratory data analysis from this particular library. And I'm going to import this particular Kaggle from the Kaggle IM. So this thing will be coming automatically. Okay, till this thing, everything, this particular first snippet will be coming as such, and then we are going to run it. Okay, so now let me run this particular first snippet alone. Okay, so it's executed, and it is showing like inside this first one we are having the hard.csv file. Okay, and then I'm going to import this matplotlib .pyplot as a PLT. So all these are meant for like an other functions which could be done with the help of this library. So and then I have executed this particular snippet also. It's executed, and then so you can see here df stands for the data frame. So pd is a library, so from the pd I'm going to read the csv file. Since it's a csv, I am putting like a read underscore csv. If it's going to be like excel, read underscore excel. So based upon the type of the file, I'm going to use it. So I'm just executing this, and now automatically what happens, this hard.csv will be segregating inside the df. It will be stored inside the data frame df. Okay, then I'm going to see this, what is like a top 5 rows. Okay, 8 stands for finding the top 5 rows. So df.8, if I'm going to execute, it shows like, so 8 set cp. So what are the attributes which we have seen, and the top 5 records it will be showing when I'm going to use the command head off. Okay, and then when I'm going to use the shape command, it is going to show like how many rows and how many columns are there. So totally we are having 303 rows and 14 columns are there, and when I'm going to use the command like in shape. Okay, and then I'm going to use the command info. So this info commands gives us the information. So what is the type of that particular attribute sort of a thing. So all these are like an integer in nature, and this is coming in the float sort of a nature. So based upon the type of an attribute, it will be showing that particular, in the case of data frame point of view. And in the case of this describe, it's a one which gives the statistical information about our data set, so about each and every attribute of our data set by using the word describe of. Okay, so age, what is an age? So in the case of so all the records are like a 303 records are found. So what's going to be like an average value of an age is like 54 years is an average age. And what is going to be like a standard deviation? What is the minimum value? What is the maximum value? So minimum value considered here is 29 years and the maximum value considered is 77. Similarly, for each and every attribute, using this describe word, we can get the inference about the attribute. Okay, and then we are going to check whether it is having the missing value. So as I said earlier, in the case of the pre-processing, missing value is going to be a potential problem. If the missing value is going to be, it's going to be a potential problem. But in this particular data set, luckily we are not having the missing value, so it is showing like none of the all 303 records are complete. It's not having any missing value, so that's what it is trying to show here. And then I'm checking out with any outliers or there, and all things are perfect. And then I'm just drawing the box plot. It's like a sort of a visualization. So for the box plot, I'm using this particular code, and based upon like an requirement, we can fine tune it. But basically, I try to show that we can make. And again, like in the case of the Python, each and every day we are getting number of libraries. So now even this visualization is could be seen better by using the PySpark. PySpark, it's a part of a Python. PySpark, this way also we can do, but there is no hard and fast rules in the case of the Python. Okay, and similarly I'm trying to visualize the each and every attribute. So now I am visualizing this target like presence or absent, like it's there or not. So you can see like out of this 303 records, so 160 records says like the person is having like an having a heart problem, and the remaining 147 or something like that, there is no heart problem in that particular 303 records. And similarly, I'm trying to show between the age also. So what's going to be like an age and whether the heart disease is present or not. So now we are making the inference between the age and the target label. Okay, so that's one sort of inferences. And then next is going to be like in sex and the target point of the view. So again, in the case of the sex, we are having the male and the female. So how many male are having the heart disease and how many female are having or not having. So this is one way of inference. And similarly, I am trying to make the relationship between this trust BPS attribute with the presence or an absence sort of a thing. And similarly, I am trying to make the comparison with the cholesterol with the prevalence of the heart disease or not. So obviously, when the cholesterol is higher, the heart disease is higher in nature. And similarly with the talach and the count point of view, and similarly with the other attributes also, I'm trying to map it. Okay, these are like finding like a relationship between each and every attribute with the target point of the view. So other than this, we are having a heat map. So in the case of a heat map, it will be showing like an table correlating all the attributes with the target point of the view. That is also there, which helps in the correlation point of view. Okay, and then now I'm going to try to apply the algorithm over this. So for this, I'm just trying to drop the axis, and then I'm going to apply the scalar, standard scalar and model building. So in the case of this, I am building the model using the SVM, support vector machine. And this is the line which tries to, sklearn is meant for the model building stuff. And you can see like a test size is 0.2. It means that training size is 0.8. Okay, this is the line which tries to tell about the pattern of model which we are going to build. So it's very clear, like I'm using the 80% of the data for the training and the 20% for the testing. And it is very fast since it's like in CSV, it's not that cumbersome. And SVC stands for the support vector machine. And then I'm going to use the kernel, this particular method. So all this comes under the optimizes. Okay, hyperparameters, we can tell them like in hyperparameters what value am I going to give. So for this alone, you are supposed to refer the concerned pages to think about what value can we give for this SVC. So what are the parameters for that? So that could be based upon the analysis only. We can give this parameters, hyperparameters could be fine-tuned. So I'm using this support vector machine, and then I'm getting the accuracy values, precision value, recall, F1 square support. So it's very clear, like accuracy is something like 0.77, and then similarly precision recall is quite better, not the best, it's quite better in nature. So 0.77 is an accuracy. And similarly, I'm trying to apply the ADA boost classifier for this So that's going to be the another one algorithm, which machine learning algorithm, which I'm trying on this. Similarly, I'll be getting that, and I'm getting like 0.83. Okay, this is very basic work that could be done with the help of a data set, with the help of the basic machine learning algorithm. So in this, I can give the result like for this particular data set, ADA boost is going to having the higher accuracy. So for the testing in the near future, for building a system, I may be using the ADA boost for the working point of the view. So this is one way of interpretation. So do you want this file actually? Yes, no. Okay, fine. Download notebook, so you can open it in the similarly in the just open notebook and download it from for you. So this will be in the IPYNB extension. So you can either open in the Google Colab or a Kaggle or even in the Jupyter. But in the case of a Jupyter, kindly check on with the in that importing stuffs. Okay, and these are like basically on the machine learning point of the view. The other thing, like to coming to the end of the session, I like to tell like the next phase of this machine learning is a deep learning, and hope all will be working with n number of deep learning algorithms. Okay, so this hope definitely you may knew this. So this Kerastat application gives you the various uh, deep learning based algorithms. So transfer learning algorithms, to precisely called transfer learning algorithms. So as of now, many are working with this. Like it started on with the VGG 16 and the 19. It's based. It will be working based on the ImageNet. So ImageNet is like very old. It's a very long back they have started that ImageNet challenges. They'll be putting the various images, and via that they'll be building the various models. So exception VGG 16, 19, ResNet things. And as of now, we are with this efficient net B7. Still, we are having so many things, mobile net, all those things. For that, you can refer this, and similarly, you can start code it in the Google Colab or the Kaggle point of the view. So I guess I am ready for the any questions. So if any other informations if you require, you can contact me. Any queries?
Okay, participants, if you
So
have
this
any
is my
queries,
information.
either you can unmute yourself and ask, or you can post in the chat box so
So
that
I
can
am,
be answered.
yeah, I am serving in the School of Information Technology and Engineering, and this is my mobile number and this is my email ID. If you have any other queries, you can contact via the mail or the email ID. I am ready to help you out. Yeah, tell me. Someone started with something.
Thank you, ma'am. And now, participant can ask your query if you have any to your honorary guest.
There is one query by
Yeah.
GS. What repository for medical 3D printing data set? This is in the chat box, ma'am.
Yeah, I'm seeing the chat box actually. Ma'am, actually, in the case of this 3D printing data sets, you can check it in the mainly in the Harvard. In that itself, we are having so many medical related data sets. To be specific means you can check out with some health related websites. But I guess you can just check the Harvard and then this Google. All those things is more than enough for you to check. And then regarding the serious data, can you please say some processing step? So can I know like what sort of serious Vasavi, time series data. Hello. Yeah, time series data. So in the case of a time series data, we'll be having this ARIMA model. All those models are there, time series data sort of a thing. And in the case of a deep learning perspective, you can think on with working on with the time series data with a LSTM point of the view. Long short-term memory related to that, you can start working in the time series with the LSTM.
Any other queries? Oh, okay. Thank you everyone for being here with us today. A special thanks to ma'am for sharing your knowledge with us and giving your precious time and words. Thank you, ma'am.
Yeah, thank you, Professor. I want new the feedback of this session.
Yeah, ma'am,
Yeah,
sure, I will provide you when I
yeah.
get.
Yeah, sure. Thanks for all your patient listening, and you can approach me via this mail ID or the mobile number whenever required. I can help you out in the machine learning and the deep learning stuffs. Thank you.
Okay.
Thank you all. Yeah, thank you. Can I leave, Professor?
Yes, ma'am.
Yeah.
Now, dear participant, next session will be start at 2:30, sharp at 2:30 with MNIT Jaipur Professor Rajesh Kumar. So now you can leave and we can join at 2:30.